Hello everyone, welcome to another wonderful moment in this our class. Yeah, today, after watching this video, you will not have problem with calculations in mathematics that has to do with longitude and latitude. Yeah, I want you to pay attention and then make sure you watch to the end so that you'll be able to see some other calculations that will be coming up after this. And if you have not subscribed, I encourage you to do that. Subscribe and share, and then tell your friends about it. Now here we're going to look at latitude and longitude. In longitude and latitude, these are some imaginary lines that we use to identify places or to locate places in on Earth's surface. So in this case, we look at it on the board. What we have here, we have a drawing that's trying to describe what we have. To show up the imaginary features of the Earth. Now the first one we have here is the North Poles. The North Poles. That's the North Poles. That's according to the rotation of the Earth, it rotates within the axis of the North South Pole. The Earth rotates around the North and South Pole. So other line that we have here is the longitude, we have the latitude, and then let's talk about them briefly. All these lines we see gives us some of them give us a great circle and a small circle. Now the one that give us great circle are these ones that cut the Earth into two equal parts, and their radius of this great circle is always equal to the radius of the Earth. While we have other ones that we call the small circles. These small circles, they do not cut the Earth into two equal parts, and most of their radius is different from what the radius of the Earth. And now when we talk about the latitude, latitude is one of the lines that normally give us some of this small circle in question. For example, this one here that called the Earth, the pole, the one that called the pole at right angle or perpendicular is what we call the latitude. If you look at it, you find out the other one, the one that cuts the Earth into two equal parts, and then is what we call the equator. This is the latitude, another latitude here, cutting the pole at right angle. This one being that it cuts the Earth at the center, we call it what? Where it's known as what? Equator. While these other ones is example of the one that give us with regard we call the small circle. Now all these areas, in this area you find another one, we have the longitude. This longitude is also a line that cuts the Earth into equal parts, and it cuts from the North Pole to the South Pole, as the case may be. We move from there down, giving us what we call the meridian. All these longitudes form what we call the great circle. They all form the great circle. Now let's go to other things. Now, therefore, being that they cut the Earth into equal parts, each of the time you want to make calculation or determine a position or distance in it, it's important you also use that radius of the Earth to appreciate them. So in this case, we can also use this formula of circle, which is always where this R stands for the radius of the Earth. Now, but unlike that, when we come to the other one, the latitude, that this latitude you see here now is what we call they form what we call the parallel of latitudes. Parallel of latitude in the sense that they are parallel to each other, and also their radius tends to be different from the radius of the Earth. In that case, if you are to find this radius, you have to find their radius in your calculation of anything that falls around this zone. If you want to calculate anything that falls around this zone, you need to what? Get their we need to get their radius, and their radius tends to be, let's say this one now, this is their radius, and we know that radius of the earth is this, because from this point, center of the earth to this other end, we have the radius of the earth. But if you look at it very well, you find out that these other ones are not exactly from the center of the earth, not exactly from the center, because they cut the earth off from the center. So assuming we have an angle here, angle theta here, we know that being an angle here is also alternate to this other words angle. They are alternate to each other. Now another thing we can do here, in order to get the radius of this, to calculate this radius, the next thing we do is that we make r we make the r the subject of the formula. But then before that, we need to really consider this as a circle, as a triangle. We consider this as a triangle. Considering it as a triangle, you notice that this is a right angle, and this one is angle theta, this other one is another angle. In that we can use our rules. This is SOHCAHTOA. In SOHCAHTOA, that means here is what? Adjacent to the angle. This is hypotenuse to the angle. In other words, we can use cos. But we are coming for cos. That means cos theta is equal to what? Adjacent, which is r, over what? Hypotenuse, which is big R. The small r over big R. Then making r the subject of the formula, we can multiply through. We have small r to be big R cos multiply cos theta. So with this, we'll be able to solve any problem that deals with what? The breadth, the latitude, the parallel of latitude. For each time we're going to solve a problem with that, that means in this case now, instead of using this value, the value that can substitute that will be theta times 2 pi r, and then 2 pi r cos 2 pi r cos theta. With this now, we'll be able to solve any problem that falls within this parallel of latitude. So like I said, after this thing, thank you for watching to this end, and it's an indication that you really want to learn more. And after this video, next one is coming up to show you how to use some of this calculation, how to calculate the best circle, how to calculate something that's in the best circle, and then the one that are in small circles like the parallel and latitudes. Thank you so much. Make sure you share and click the like button. Thank you so much.